Hello, this is Concrete Path. Here we have the lecture that's saying that classification of soils. Classification of soils. So classification of soil, we say this is actually sorting of the soils into different groups. Sorting of soils into groups. Sorting of soils into groups. And that those groups and those groups and the soils in a particular group would show similar behavior, similar character. So in one group they would show similar behavior in one of the groups. So similar behavior, okay, according to similar behavior. And we classify the soil. We are going to classify the soil based on some simple index properties. We have studied the index properties. So based on those properties, we are going to classify the soils. As like that, we have one of the property was your particle size distribution. Particle size distribution. One more was their plasticity characteristics. Plasticity characteristics. Plasticity characteristics. So based on these two properties, we are going to classify the soils. And few systems have emerged for classifying the soils. So few systems are there that are used to classify the soils. And first one among them is USCS. Second one is there, that is Ashto. And third one is there, what you call as ISSCS. Let's talk about the first one, that's USCS. Okay. USCS. That's a unified soil classification system. Unified soil classification system. Okay. And this was given by Casagrande. It was given by Casagrande in 1948. For when there was construction of that, what do you say, airfield construction. So it was given for airfield construction. After that, it was used for all other civil engineering works like dams, embankments, design of those. So this is your USCS. Okay. Now it's saying that our soils can be classified as, one is your fine grained soils and one is your coarse grained soils. So for the coarse grained soils, it's saying that we are going to use the index property of what you call as particle size distribution. And here we are going to use, for the classification of fine grained soils, we are going to use the index property, that's plasticity characteristics. Okay. So we would say that this USCS has separated the soils into four major groups. Four major groups of soils here we have. One is your coarse grained soils. Next one is your fine grained soils. Third one is their organic soil, and fourth one is a separate category, that's we call it as peat. Okay. Peat is actually that we have high amount of organic matter. So that's a separate category of peat. Okay. So this is all about that first kind of system, that is USCS. If we talk about the second one, that's ISSC, that's what you call as AASSTO. So that is the second one. This is American Association of State Highways, State Highway and Transportation Transportation official. Okay. So it's actually, we can say that this classification would be used for classifying the soils for your highways. If you want to design highway, for that you need those soils and that all those embankment, subgrade soils, etc. And for that you are going to use this method for highways. Okay. So in this one, we say that each of the we have few groups here. We have each of the group is classified, and if there is any soil in one of the group, is what you call as analyzed or distinguished by a factor that's called as group index. So it tells us about that particular soil in a particular group, particular soil in a particular group, that what's its character all about. So it tells us the feature of that soil. So this is your group index, and we have the formula for that group index calculation. That is 0.2a plus 0.01 BD plus 0.005 times AC. Let's say that we have that n, percent n, that's percent finer, that we write as percent finer than 75 micron Cu. So that means how much percent of the particles are finer than 75 micron. So how much percent is actually a fine grained soil? How much percent of the total? So that's percent n finer. And we write that what is the value of n? That's actually n minus 35. Value of B is n minus 15. Value of C is liquid limit minus 40. And value of D is plasticity index minus 10. Is it? I think it is 20. I have to check it. 20, 40. Okay, it is 40. It's 40. And the range for this one, what you call as this n minus 35, its range is 0 to 40. We take it. This value is also in the range 0 to 40. This value is in the range 0 to 20. And this is also in the range 0 to 20. So that means if there is any value that's negative, if there is any value, any term having negative value, term has negative value, so we have to substitute that value as 0, put value of 0. And if the limit is going greater than that 40, so we have to keep the maximum limit here. We have 40 for the first two. We have to keep the first that maximum limit here. If the value, let's say n minus 35 is 43, so we have to keep that value as 40 maximum limit. Okay, so based on this, so we say that your GI value can be minimum value. So your value of GI minimum value could be equals to 0, and GI maximum value could be equals to 20. And if the value of GI is minimum equals to 0, it means that your soil is a very good soil for your subgrade material. So it's a very good soil, I would say. Good for subgrade. It can act as a good material for your subgrade. Very good material for your subgrade of the payment. So this is subgrade is the layer for your payment road. Okay, very good material for the subgrade. And this one, if the value is 20, so we say that poor material is poor. Okay, poor is material. Okay, this was all about that. What you say? Have second one. That's Ashto, and we have here eight groups. We have here 8 groups of soils. 8 groups of soils. A1 to A8. That means A1, A2, A3, and A8 finally. And this A8 is corresponding to organic soils, or we can say this is for the peat. Okay. Now coming to our main kind of system, that is the third one. That's our main job to perform. That's ISSCS. That's our main job here. ISSCS. So that's Indian soil classification system, Indian standard soil classification system, Indian standard soil classification system, given by Bureau of Indian Standards, BIS. Okay, so this one is actually derived from USCS. You can see the name also. So it's derived from the USCS, and there's only one major difference. Is there in that fine grain soils classification. In the fine grain soil classification, the main difference here is that USCS has kept the fine grain soils into 2 categories. Fine grain soils into two categories. One is your high and one is your low. So high and low, that's about compressibility. That means the fine grain soil is either high compressible or it's low compressible. Okay, but your ISSCS CS has talked about that we are going to classify the fine-grained soils into three categories. Into three. One is your low, one is your intermediate, one is your third one is your high compressible soils. High compressibility. So this one is the extra part here. It has separated the two, that's low and high, and there is one more transition, that's intermediate compressibility of those soils, intermediate compressible soils. So that is the major difference between ISSCS and USCS. Okay. Now here we have three broad divisions of soils. Here we have three broad divisions of soil. One is that's coarse grain soils. One is your coarse grain soils. As that of a we have four groups in what we call as USCS, and here we have three broad divisions. Here we have three broad divisions. One is your coarse grain soils. Next one is that fine grain soils, and third one we can call it as organic soils. Or if the organic content is very high, so we are going to keep it as PT. This is PT, third category. So coarse grain soil means either it can be sand or it can be gravel. That means if there we have, if we talk about the sieve analysis, what was the smallest sieve we have? Smallest sieve. If this sieve was 75 micron, if the weight, if the total percent, if there was weight of total 100% total weight of the soil, this was the total percentage of the soil, and if more than 50% of the soil, if more than 50% of the soil is going to retain on this sieve, that we can say this soil is coarse grain soil. And if I would say if passing is greater than 50% on this 75 micron sieve, if out of the total soil 50% greater than 50% is going to pass from 75 micron, so that's your fine grain soils. So this is the characteristic. This is that classification based on the percentage finer than 75 micron. So here we write if percentage that's if percentage n greater than 50%, that means this is if the 50%, if the particles are finer than, if the total particles are finer than if the total particles are greater than 50%, that are finer than 75 micron. And here we can write if percentage n less than 50%, that means they are retained, that means retained on 75 micron. That means more than 50 percentage of the total solid particles are retained on 75 micron. That's your coarse grain soils. Okay, third one is that if the soil is having high organic content, organic matter, so that we write it as peat category. Okay, now we would say that from coarse grain soils itself, it can be either gravel or it can be either gravel or it can be either sand. And similarly here we can say your fine grain soil, it can be now either silt or it can be clay. And we also classify we also put the what you call as, we say that either it can be silt or it can be organic soil also. If the organic matter is very much, then we can say this is your peat soil. So if the organic content is less, so we can keep it as organic soil. Here we have it in the fine grain soils. Okay. Okay. So let's go. Here we say we have basic soil classification on the basis of size. If we talk about the grain size, so from that also we can say there is some classification. We have touched it also earlier, I would say. Now let's say that your grain size is in the range 80 millimeter to what you call as 4.75 millimeters. So that we call it as gravel. Now we can say we would say that gravel can be either coarse and it can be either fine. So for coarse gravel, I would write the range of the particles is in that 80 millimeter to 20 millimeter, and for the fine gravel, the range of the particle size is in the range 20 to 4.75 millimeters. And similarly, if there was sand, the range of the particles is in here we have 75 micron to that 4.75 millimeters. 4.75 millimeters. And here we can write we have three different those subgroups also. One of the group here is we can say that's your fine, one is your medium, and one is your coarse sand, fine sand, medium sand. For the fine sand, your diameter is your particle size is in the range 75 micron to that would have 425 micron, and for this one we have 425 micron to that 2 millimeters. And for the third one, coarse sand, that is 2 millimeter to 4.75 millimeters. After that, we can have fine grained soils. Clay and silt. For the silt, your particles are less than 2 microns, and for the silt, your particles are in the range 2 micron to 75 micron. That's all about that classification based on grain size. Now, if I say that about this third method, that's ISSCS classification, we are going to use that few symbols. We are going to use few symbols, few prefix, and few suffix. Let's talk about those as per the condition of the soil. As per the condition of the soil, we can have the names, different names we can write here. Let's go for that. If we have a soil, if we talk about we have a soil, there is a soil type. And soil type, let's say that soil is gravel, and let's say soil is sand. Soil can be silt, soil can be clay, it can be organic soil, and it can be peat also. Now for those, we are going to write the symbol for your prefix, that is the start of that representation of that particular soil, that is the prefix, and this we are going to write that prefix symbol. So for the gravel we can write G, for the sand we can write S, for the silt we can write M. So for the silt we are writing M, and for the clay we are writing C, for the organic we are writing O, for the peat we are writing PT. So these are the symbols used for your prefix that denote the particular soil type. Prefix says what is the soil type. So your prefix says what is the soil type. And now if we talk about the subgroup, that's actually talking about the gradation. And if we talk about the subgroup, now we are saying that it means, let's talk about that. We are saying well-graded soil. For that we are going to use suffix. For that we are going to use suffix. That means we are going to write a particular soil by two different words, by two different alphabets. Let's say we are going to write GW. This means that your prefix is G and your suffix is what you call as W. This means that we are going to write your soil is well-graded soil, well-graded gravel. So your suffix is talking about that well, that is W, that means it's well-graded, gradation. And G is the prefix, it's the soil type, so this is your gravel, that is well-graded. Okay. Similarly, if we talk about poorly graded soil, poorly graded means we can write it as P. After that, there might be, let's say that there is, we are going to write silty. Silty means we are going to write it as M. We are going to write it as M. And if the soil is that it's clay soil, so we are going to write C. This is different from the first one. First one use your clay. That is the prefix point of view, and this one is your suffix point of view. That's also denoted by the same. Let's have a that distinction between the two. Let's say that your suffix is let's say that your prefix is G and your suffix is C. This means that your soil type is gravel. That means your soil is predominantly of the gravel type, but you're having little bit of clay also. You're having little bit of clay also, so we can write that this is your clay gravel, clay gravel. This is gravel, but we are having little bit of clay there, little bit of clay. We call it as fine. So with fines as clay, you are having that gravel. That means there is some gravel, and we are having a gravel soil. This is gravel, but we are having little bit of clay also there. So that is GC, clay gravel. Okay. So that's this fix, silty and clay. After that, we can have if the water content, what liquid limit is less than 35%, we write that soil as that what you call as L. We write that as L. If the liquid limit is in the range, it is in the range 35 to 50%. So we're going to write it as I. And if the liquid limit is greater than 50%, so your clay we are going to write this fix as H. So these three, they are talking about that compressibility. They are talking about the compressibility. So if that means your liquid limit is related to the compressibility. More liquid limit, more compressibility. That is low compressibility, low, intermediate, and high compressibility. Okay. These are your suffix. So let's go for the classification now. Let's go for the classification of fine grained soil. Fine grained soils. Let's talk about the fine grained soils. Let's talk about the fine grained soils. Let's see what's all that stuff related to the fine grained soils. Okay, let's go. Let's go for the fine grained soils. Fine grained soils classification. Okay. So we said that your fine grained soils are classified based on the plasticity characteristics, based on the index property of plasticity. So plasticity characteristics. On the basis of plasticity characteristics, we are going to define classify those soils. So for the plasticity character, we have one chart. We have one chart that we call as plasticity chart. Plasticity chart. Plasticity chart. So this chart is all about that. This chart is all about that. If we have what you call as, if we have a liquid limit in the horizontal axis, we have liquid limit. We have water content. Actually, we have water content. We have water content. From this side, we are having water content, and from this side, we are going to have that plasticity index IP. From this side, we are going to have plasticity index. Okay, and there is one line. There is one line. The equation of that line. There is a line that we call as Atterberg line. Atterberg's line. So because this is all about plasticity, consistency, limits, Atterberg's limits. So that's why we have Atterberg's line, and the equation for that Atterberg's line is that y equals to mx plus a. And similarly, we are having this in terms of this IP and W. So we're going to write the equation for that Atterberg's line is actually IP for your Atterberg is equals to that's 0.73 times liquid limit minus 20. Liquid limit minus 20. So this is a line. So if I try to have that line here, I would say at water content of 20, this is going to cut the horizontal line. So this is your IP line. This is your IP line. IP line. Okay. We can write this is A line. Actually, this is A line. Atterberg line. A line. Okay. And it means that this line is actually trying to separate. So this is an interface. So it's trying to separate. It separates that clay soils from silty soils. Clay soils from silty soils, or organic, we can say organic soils. So if your actual clay, the plot, let's try to understand that from here. let's say that what we are going to perform here. Let's say what we are going to perform. The procedure here is you have a particular soil. You have a particular soil. You do one thing. You calculate the liquid limit of that particular soil. You calculate the plastics limit of that soil. Calculate then the plasticity index of that soil. Calculate the plasticity index of the soil by this equation. Okay. Now there might be some value. There would be some value. Now you would say corresponding to your liquid limit, corresponding to your liquid limit, corresponding to your liquid limit here. You would say, yeah, actually this one is your equation for the liquid limit. Actually, this water content is about the liquid limit. This is WL. Okay, this is WL. So I would say corresponding to your WL, corresponding to your liquid limit value, you would be having this IP value somewhere. So corresponding to some value of WP, let's say that WP is somewhere here. This is your actual WL of the soil. Liquid limit for your soil is somewhere here. But you would say, what's my value of IP? What is the value of IP of my soil? So it can be either somewhere here, some value here, or it can be below that line. It can be either above the line, it can be below the line. So for that we had two different possibilities. So that's why we are going to write that. If your first possibility now is that if your IP of the soil, is it's greater than IP of the A line, it's greater than IP of the A line. That is the equation of the IP. That means you are having that particular soil. Okay, you are having that particular soil. You substitute the value of that liquid limit of that particular soil here, and you would get that value of IPA. You would get that value of IPA. Now, if your value of IP soil is greater than IPA line, that means your point is somewhere above the A line. That means your point is above the A line. Your soil is above the A line. Soil above the A line. We can write soil is above A line. So if your soil is above A line, so we can say your soil is actually clay. Your soil is actually clay. So we say that above the A line, your soil is clay. Your soil is clay, and below the A line, your soil is what you call as silt, or it can be or we write or O, organic soil. It can be silt or it can be organic. Usually we would go with silt. Okay, it can be either clay or it can be silt. So this A line separates soils it separates clay soils from silt soils. So above the A line we have clay, below the A line we have silt. Okay. Now, okay, this is one of the parts. And similarly, if your IP of the soil is actually less than IPA, that means IP corresponding to A line is more. That means your soil is below the A line. If your actual soil is below the A line, that means your soil is actually slit. Your soil is actually slit. Your soil is actually slit, or we can have organic also, or organic we can write. Okay. Okay. And there is one more transition. Somewhere here. There is one more transition. Here. Let's first have those three different kinds of those what we write as prefix, that suffix LIH. Let's talk about these also based on the liquid limit. So your actual that diagram plus the T chart would be somewhat in this fashion. Let's remove this one now. Let's try to have a proper understanding now. I would say you are having this liquid limit somewhere here at the value of 20, and somewhere here we would be having 35 also, liquid limit of 35, and somewhere here we are having liquid limit of 50. Okay, now corresponding to that, let's say this is your WL equals to 35 line. This is WL equals to 50 line. So if your soil, let's say that soil is somewhere here. Let's say your soil is somewhere here. So we can say this is your clay soil, but this is clay, but but intermediate compressible. Why? But intermediate compressible. Because your liquid limit is in the range 35 to 50%. And if your soil is somewhere here below the A line, but in the same range, we can say that this is your silty clay. Yeah, this is your silt. The soil is silt, and its compressibility is in the intermediate condition. So this is Mi. We can write it this one as Mi. And similarly, you can have one more. Let's say that soil is somewhere here in this range. We can say your liquid limit is more than 50%, so it's actually high compressible. So your suffix is high compressible, and your soil is actually below the A line, so this is slit. So we can write this is your MH. This is MH. And for the third one, that if the liquid limit is less than what I call as 35%, if the liquid limit is less than 35%, so this one we can write this is slit because soil is below the A line, and this is slit, and we can write this one is your low compressible. This is ML. That is that what you call as silt, low compressible silt, low compressible soil, or that's silt, ML. Okay. And similarly, you can have from the top also we can write that there is soil. If the point is above the A line, that's clay, and if the liquid limit of that soil is greater than 50% liquid limit, so we can write that your soil is actually highly compressible clay, high compressible clay, CH. And here we can write that your soil can be clay, but your low compressible clay. Okay. Now there's one more line that's we could write it as a U line somewhere here, that we have U line. We don't use that U line. We don't use that above that U line. That means there is no soil that exists below that. Above that A line, there is no soil that exists. But we would say that there's a value of plasticity index equals to 4, and there's a plasticity index of 7. If the IP value is in the range 4 to 7, there is one transition of the soil. There is one transition of the soil. There is one transition of the soil. So this transition of the soil. So this is your transition of the soil. That one more statement, that for IP value in the range, for value of IP of the soil in the range 4 to 7%, there is a transition. This we would say that your plasticity chart has a transition state. For that, you are going to use the dual symbol for your soil. You are going to use the symbol of dual symbol. That means we are going to write M. Now we are going to write here M. This is slit. It can be slit also, and because this is L, because the liquid limit here is less than 35%, you can see liquid limit is less than 35%. So we can write this is ML, or it can be clay also, and CL. We can write this one as ML-CL. That is, it's having both characters. So there is no definite distinction of that soil. If its value of IP is in this range and liquid limit is less than 35%, so we say that we are going to keep that soil as a separate category in this symbol. That's we write it as dual symbol. That means it's both silt and both clay. So it's having features of both kinds of soils, and it's because its liquid limit is less than 35, so this is low compressible. It can be either silt or it can be clay. Both characters, silt. That's ML-CL. what do you call it? Let's write it in this way: CL-ML. So this is the dual symbol for that range 4 to 7 IP. They are having characters of the both kinds of soils. So the distinction of that particular soil is difficult to have. Okay. So that's all about what you call as fine grained soils. Now we would say that what about coarse grained soils? What about coarse grained soils? Now, based on the fine grained soils, let's say that we're going to take few problems and we would get some understanding. Let's go for few problems for your coarse fine grained soils. Let's take the first problem, that we're having two kinds of soils. Fine grained soils are there. Fine grained soils. Let's say soil number 1, soil number 2. Okay, one is your A, one is your B. It's having liquid limit of that 44%, and this one is having 55 liquid limit. Here we have plastic limit of 20. Here we have 35. We have natural condition, that's liquid limit at that's the water content in the natural condition was observed as observed to be 30. This was your water content natural, that was 50. And we need to tell which of these soils, which clay, or we can say which soil is more plastic, which soil is more plastic, which of these soils is more plastic, which of these soils is more softer in consistency, more softer in consistency, and which is more prone to settlements. That's compressibility. More prone to what you call as settlements. Delta settlements. That means compressibility. Okay. For same load, which one is going to have more settlements for the same load? Which of these soils? So these three statements we need to draw, with three conclusions we need to draw about these two soils: consistency, plasticity, and your what you call as compressibility, that is settlement. Now I would say that for plasticity I need to calculate plastic index. For the calculation of plasticity, for the calculation that whether the soil is plastic, the comparison between those, for that I have to use the concept of plasticity index, that is liquid limit minus plastic limit. Liquid limit minus plastic limit. Let's calculate the values for your soil A and soil B. So that is actually 44 minus 20, that's 24, and this one is your 55 minus 35, that is 20. Now I would say that your IP value for soil A, so we can conclude here, your value of IP for soil A is greater than IP value for soil B. That means your soil A is more plastic than B. Can we say that? Your soil A is more plastic than soil B. Okay, go with the second part. Second part, that's consistency, softness and consistency. For the consistency, which of the parameters, which of the index we are going to use for the consistency? Do you have the concept of consistency index related to consistency for your fine grained soils? So that talks about the consistency. What was the equation for that? What was the formula for that? Liquid limit minus natural water content minus, divided by IP value, WL minus WP. Do you know the equation? So let's go for those. Let's calculate the value of IC. Let's go for the value of IC. So IC would be equals to liquid limit minus natural water content divided by IP value. So here we can write that we are having for the soil A, we can substitute the values here. I would write 44 minus natural water content of 30 divided by value of IP 24. And in the second one we can write your liquid limit of 55 minus natural water content of 50, divided by the value of IP, that's 20. And you would see the value is coming to be equals to at 0.58 and 0.25. 0.58 and 0.25. Your value of IC is more for your soil number A. Okay, so we would say that your soil B is softer in consistency. Soil B is softer in consistency. We say if your value is less, so B is softer in consistency. So we have studied the value, that IC value, the value of IC and its range, and it talks about the consistency. Okay, B is softer in consistency than A. Now third one is there, that is the settlement or compressibility. Settlements or compressibility. Now for that we can have the classification of that. We can have the classification that if your value of WL is in the range 35, that 35 to 50%. One was that 50% less than 35. So we need to check that, and we can also check whether the soil is. We can also check whether the soil is clay or whether the soil is what you call as sillet. We can check those two also. Let's go for the third one. That is the calculation for settlement or compressibility. The third one we need to calculate for the compressibility or settlement. Settlements. For that, let's go for the soil A. I would write what is the equation for your IP. So your IP for A. I can write Your value of IP for A is actually 0.73. Liquid limit minus 20. Liquid limit minus 20. Liquid limit minus 20. And your IP for soil B, IP, that is the A line, actually, equation of A line. And I want to say what is the IP for A soil, what is the IP for B soil. So we have the equation 0.73, liquid limit minus 20. Liquid limit minus 20. So these values we have. What's the value coming? So for the first soil, that is coming out to be 17.52. And for the second soil, that's soil B, it's IP for the IP for the A line, that's coming to be equals to 25.55. Now we need to compare. That. We need to compare based on the value of A line, whether your A line is whether your soil is below the A line or it's above the A line. If your soil is above the A line, so we can say that soil is clay. If your soil is above the A line, and we can say that soil is clay. Let's say that we have those limits. This is liquid limit of 20. This is 35, and this is 50. Okay. And we need to check where our soil is actually lying. Where your soil is actually lying. I would say, what is the liquid limit for your soil A? What is the liquid limit for your soil A? Can you tell me? Your liquid limit for soil A is 44. 44 somewhere. 44 is somewhere. 44. This is your 44. Somewhere here. Now we need to check whether your point is above or it's below. So for that, your soil A, what is the IP value for your soil A? What is the IP value for your soil A? Is that 24? Your IP value for soil A is 24. But what about the A line? What about the A line? That is 17.52. So that means your soil A is above the A line. Above the A line. Can we see that? Your IP for A, IP of the soil is actually 24. That is greater than IP for the A line. Can we say that? So here we write that soil is that is the soil is clay. So the soil is clay. So here we can say your soil A is somewhere here. That is actually a clay. Soil A is somewhere here. Okay. With that value of IP equals to 24. And for the second soil, that is it's having value of IP how much? 20. It's having value of IP as a value of 20. It's having a value of 20. But what about the A line? What about the A line? It's 25. So for the soil B, your IP value for the soil is actually less as compared to the IP for your A line. So this is actually slit. So you can say that soil B is slit. So it would be somewhere here. It would be somewhere here because your liquid limit for the soil B is 55. You can see liquid limit for the soil B is 55. So that means it's highly compressible. So it's greater than 50% 50% liquid limit. So it is somewhere here. And because your point soil is below the A line, so this is, I would say, this is slit and it is MH. So your soil B is MH. Soil B is MH, and your soil A is actually clay, but what? Clay but intermediate. Clay intermediate. So from that I can say your soil B is more compressible. Soil B is more compressible. More delta would be, more settlements would be for your soil B. Okay. Okay. We can generalize that. That was all about the first problem we can have. So it's including all those concepts of your fine-grained soils. Let's take that few simple problems for your fine-grained soils. Fine-grained soils. Okay. Let's say that we are having a soil. We're having a soil. Soil is there. Its liquid limit is 58. Its plastic limit is 14%, and it's saying that we have that CU of 4.75 mmCu, and on that, how much percent is passing? From that, how much percent is passing? So how much percent is passing from that CU? That is 75% of the total is passing from that CU. And what about the 75 micron? What about the 75 micron CU? So it says that out of the total, 75% is passing from this CU. 75% is passing from this CU. 75% is passing. So that means what can you conclude from that? What can you conclude from that? I would say we are having two different sieves. One is your sieve number one. One is your sieve number one. That's actually what you have, 4.75 sieve. And there is one more sieve that is 75 micron sieve. That means out of the total 100% of the particles, your 25% particles are retained on the 4.75. That means your gravel percentage is 25. You are having 25% of gravel, and I would say that 75% is passing. And once it passed here, and I would say what is the retained in the range 4.75 to 75 micron? What is the percent that is retained here? I would say that retained here is 0, because that 75% has passed 75 micron sieve. 75% has passed 75 micron sieve. So that means your finer particles are actually percent n is actually 75%. But that means sand is actually 0%. Sand is 0%. Sand is 0%, and finer is 75. So from that, if you have the classification system, I would say if your percent finer is greater than 50%, if your percent finer is greater than 50%, that means that the soil is actually fine grained soil. Soil is actually fine grained soils. We say that out of the total 100% of the soil, we are having 25% gravel, sand 0%, and fine grained part as that is 75%. It's actually greater than 50%. That means more than 50%. If more than 50% passes 75 micron sieve, that means this soil is fine grained soil. So we can classify that your soil is fine grained. Now there is no tug of war between whether the soil is what you call as slit, or whether the soil is clay. Whether the soil is clay or whether the soil is slit. For that, I had to use that concept of plasticity chart. For the fine grained soils, we use the chart of plasticity. So for that, let's calculate the value of IP for your A line. Let's calculate for your value of IP for the A line. Liquid limit minus 20. Let's say what is the value of liquid limit given to you. That's 58. Your liquid limit for the soil is 58. That's 58. We can write here 58 minus 20. 58 minus 20 into 0.73. What's that value coming to be equals to? 27.44. And what about the IP of the soil? What about the IP of the soil? What about the IP of the soil? That is liquid limit minus plastic limit. What is that value? 58 minus 14. 58 minus 14, what is that value? 44. So your 44 is actually greater than 20. So that is, I would say, your A line is below the soil, or I would say soil is above the A line. Soil is above the A line. Soil is above the A line, because IP for the soil is actually greater than IP for your A line in the y axis. So where was that plasticity chart? I would say your soil is somewhere somewhere above the A line. Now if I say that there is some 35% liquid limit, there is some 50% liquid limit, and this is your liquid limit, and from this side we are having that value of IP. Now there is a, let's say that 27.4 was somewhere here. This was 27.4, and our value of 44 was somewhere here, 44. Now we need to say whether your soil is clay or whether your soil is slit. Whether your soil is clay or whether your soil is slit. So for that, I would say your A line is below the soil, or soil is above the A line. If your soil is above the A line, that means soil is clay. Soil is clay. Soil is clay somewhere here. Soil is clay. That means soil is somewhere here. And what about the value of liquid limit for your soil? What about the liquid limit of your soil? 58. 58 is somewhere here. 58. So that means your value of 44. That means your soil is corresponding to this value here. That means your soil is somewhere here, and because your liquid limit is greater than 50%, so this is corresponding to high compressible. So your final prefix and suffix for your soil is actually CH. That means it's a clay and high compressible clay, CH. That's your final notation of that, what you call as. So this was the main problem is all about in the classification of soil. Problem is all about that notation. How do you represent? What is the symbols you are going to use? That is all about that problem. That means this is all about the classification of the soil, whether the soil is Ci, whether the soil is Cl, and whether the soil is Ch, whether the soil is Ml, whether the soil is Mh, Mi. So different combinations are possible. So this is your final solution, that your soil is actually clay and with high compressible, and the clay is itself highly compressible. Okay, let's take one more. Let's take one more. Let's take one more. Let's take one more problem. We are having that sieve analysis data. Sieve analysis we have performed. Data is given to you. Data is given to you. Okay. What is the data? It's saying that 67% of the particles pass 75 micron sieve. So there is a sieve 75 micron, more than 50% pass. So that means it's a soil that is fine grained soil. Can we say that? So this is actually solution. This part is actually solution. This part is actually solution. This is your solution actually. Let's write that this is solution. Once we got that, whether the soil is clay or whether the soil is fine grained or coarse grained, that part is over from the first statement of the problem. So this is your problem all about that. 65% of the particles pass 75 micron. After that your liquid limit is there 45. Plastic limit is there 33. Now get the group symbol. Get the group symbol. Now one thing we got, that the soil is fine grained soil. Now it won't be sand or it won't be gravel. Now we would say whether your soil is, it can be either now clay or it can be now slit. And because your liquid limit is 45, it's in the range. Because your liquid limit is in the range 35 to 50%, so your prefix, your suffix is actually what? What's your suffix now? Your suffix is actually intermediate. So we got one of the part. Now we would say your answer would be either Ci or it can be Mi. Now we need to check that based on the plasticity chart. Let's calculate the value of IP A line. Let's calculate the value of IP for your A line. Let's calculate the value of IP for your A line. Let's say that we got that this was your 35, this was 50, and we got that your soil was somewhere here at a value of liquid limit equals to 45. So it can be either now here or it can be somewhere here. Now that we need to check. Let's calculate the value of IP for your A line. IP for your A line, that is 0.73 liquid limit minus 20. What's the liquid limit we have? 45. Let's substitute the value of 45 here, and you get AP A line 18.25. What is the value of AP for your soil? What is the value of IP for your soil? That is liquid limit minus plastic limit. 45 minus 33. 45 minus 33, that is 12. So can you compare now? Your IPA is more. So your value IPA is more great than IP of the soil. So your soil is plotted below soil point can be plotted below your A line, below the A line. So that means your soil is below the A line. If your soil is below the A line, that means the soil is slit, and because it was in the intermediate condition, so intermediate water content limit, so that's your Mi. So your prefix is M, suffix is I. So your clay is slit with that is high compressible slit. Okay. Let's talk about now what we have. Coarse grained soil classification. Classification of coarse grained soils. Classification. Now this is our second part of that classification of ISSCS. That's your coarse grained soils classification. Coarse grained soils classification. Okay. Coarse grained soils classification. Now this classification is a function of, the classification here is a function of, one is your gradation, One is your gradation of the soil. Is it gradation characteristic? Function of gradation. One more is there soil grain size, particle size, and one more is there percentage finer than 75 micron. That we are going to write as fineness. That means how much percent of the total particles are finer than 75 micron CU size. So if there is 75 micron CU, I would say out of the total 100% particles, how much percent is passing from the 75 micron? That means out of the 100%, how much percent is actually fine grained soil? Out of the 100%, how much percent is fine grain? That's this percentage finer. So we are going to write that as fines, FINES, fines. So based on these three parameters, we have three different cases. One of the cases case number one, it says that if your fines are less than 5%, if your number of particles finer than 75 micron is only 5% of the total particles, so that means this is your case number one. So here we won't talk. That means we won't talk about now. If it's less than 5%, we won't care about that 5% now. We won't talk about that fines. We won't talk about fines now in the classification. Let's see that how we classify the soil here. Let's see that this symbol would be that some symbol is a function of that suffix and prefix. Let's say that we have one of the symbol that is GW. Let's say we got one of the symbol as GW, and this one we are going to say your soil is actually well graded gravel. And for that, I have to use which of the parameters I have to use. For this condition when fines are less than 5%. For that condition, I have to use the concept of CU and CC. So for the well graded gravel, I have to use the concept of CU. That CU should be greater than 4 and CC should be in the limit of 1 to 3. So this is all about the gradation. This is the gradation. So here we are talking about the gradation. Okay, this is the part of gradation, and because the fines are less than 5%, so this part is also over. We are not talking about that, and because the gradation this is also over. Gradation is also over. Is also over. Now we are left with particle size. Now particle size here means that if it is gravel, its particles, its range of the percentage of the particles should be greater than 50% of the particles should be more retained on 4.75 micron. That means it's talking now for the third part, that is particle size. Let's see that. We are having that CU of 4.75 millimeter CU. So if the particles are retained, if we are retaining the particles, if 50% of the particles are retained on that 4.75 micron, that means the soil is coarse grained. That means the soil is gravel. Soil is gravel if more than 50% of the particles. But actually, what is the thing here? We are not saying 50% of the particles. We are saying 50% of the coarse grained particles. CGP. We are saying if the more than 50% of the CGP are retained on what you call as 4.75, that means your soil is gravel, so that we can write prefix of G. That means prefix of G is there. So for that, let's see that we are going to take few problems to understand that concept later. We are going to take that concept later. Okay. So for if your soil is gravel, if you want to write that GW, that means your soil should be well graded gravel. And for well graded, our gradation says that your CU should be greater than 4 and your CC should be in the limit of 1 to 3. And for your size character, if you talk about now size, that means your more than 50% particles. These particles are not all of those particles. These are the coarse grained particles. Coarse grain. That means it is the sum of the total sand and gravel only. It's not talking about those fines. If it's not talking about the fines. Let's see have a simple example. Let's take that simple example. You are having that 4.75 mm sieve. This is one of the sieve, and there's one more sieve that is 75 micron sieve. So this is you can have for the understanding. Let's say that we have 100 grams of soil. We are having 100 grams of soil, and we have retained on the 4.75 we have retained how much grams? We have retained 25 grams. Let's say we have retained 25 grams. Let's say that we have retained 48 grams. 48 grams. 48 grams. Okay. And our passing is less than 5%. Our percent fines are less than 5%. Your fines are less than 5%. So fines are less than 5%. Let's see that also. Fines are less than 5%. Your fines are less than 5%. Let's say that fines are equals to 4%. Let's say that out of the total, your percentage fines are 4%. That means, can you tell me what is the part that is left in the range 4.75 to 75 micron? How much we have retained? What is the retained part on 75 micron? What is the total retained on the 75 micron? That's only present from this point to below. We're not talking about the cumulative. This is all only about that particular retainage. So retainage here would be 100 grams minus 48 grams minus 4 grams. What is that value? Is that 52? Is that 48? 42? What is that value? I think that's 48. Yeah. So that means your coarse grain. What is the total coarse grain particles? What is the total coarse grain particles now? That is 96 grams. 96 grams are coarse grain particles. CGP. Let's write that this is CGP. 96 grams are coarse grain particles. But now I would say what is the percentage of gravel and what is the percentage of sand? I would say you are having 48 grams of gravel and you are having 48 grams of sand. That means your 50% of coarse grain particles are gravel and 50% of particles are what you call as sand. CGP. So that means your 50% of the total coarse grain particles are taken by gravel and 50 by sand. So for this condition, we would prefer for this case we would prefer gravel. For this case, we are going to prefer the symbol as your gravel. Or the problem if the problem mentions that if the problem does not mention the option of G, so you can prefer the value of S. But if both are applicable, so we can say you should prefer the value of G. You should apply for the value of G for your symbol. Now let's say that fines were 4%. Okay, 4%, and your what you call as gravel was 49 grams. 49 grams were gravel. That is retained. That means total 49 grams were retained on 4.75 millimeter sieve. So that means what is the total retained here? That means what is the total sand? What is the total sand in grams? So that would be actually 49 minus 3. That is 47 grams. So here in this condition, I would say you are having 96 grams of coarse grain particles, but your gravel is 49%. 49 grams are 49, and your sand is only 47%. That means your coarse grain particles, that is the gravel, is more than 50% of CGP. Can we say that? And your sand is less than 50% of CGP. Can we say that also? So that when the condition here is when we have more than 50% of CGP as gravel, so we can say this is your gravel G. Finally, this is your gravel G. So that was the conclusion here. Size of particles. If the size of particles, if more than 50% of CGP is greater, if more than 50% of CGP falls in the limit of 4.75, retain it on 4.75. So this is your gravel. Retain it on 4.75. So this was all about that stuff what we are talking about. This was all about to understand this concept of size. Now let's say that we are having sand, and sand is poor, SP. Let's say that we want this condition. Our soil is SP. Suffix of S, prefix of S, and suffix of P. This means that soil is sand, but it's poorly graded. Poorly graded sand. For that condition, what is the gradation? What is the gradation we should have? What is the gradation? Your CU should be less than 6, and your CC is not in the limits. Your CC is not in the limits. And your CC is in the not in the limits. Or there would be different possibilities. Let's see what are the different possibilities. So for, I would say, for well graded, condition has to be, both of the conditions are must. Both of the conditions are must. That is your CU must be greater than 6. Your CC must be in the range 1 to 3. 1 to 3. For well graded sand, this is the must condition. I would say this is the must condition. Both of the two must be followed. Must. Now if either one of them, now if either one of them or both of them, if either one of them or both of them are not followed, that means your soil is poorly graded. That means poorly graded. You can say that is poorly graded. So if we say that your CU is less than 6, that means your soil is poorly graded. So we can write here otherwise. So that means this is otherwise. We can write your gradation would be otherwise as compared to this. This is the must condition. If there is some value otherwise, if it is not following that, I would say that otherwise. Here we can write otherwise. That means that poorly graded is over. After that we are having sand. So for the sand, I would say your size, about the size, grain size, I would say less than 50%, particles of coarse grain particles, CGP, they are retained. They are retained on 75 that 4.75 mm. We are not talking about 75 micron. We are saying about 4.75 millimeters. Less than 50% particles of that CGP, they are retained on 4.75. That means more than 50% are passing that 4.75. That is the sand. Okay. So this was first case. Let's talk about the second case, that finers are in the range 5 to 12%. Second case is there, that percentage finer than 75 micron are in the range 4 points, that 5 to 12. Case B, case 2. When finers are in the range 5 to 12%. Finers are in the range 5 to 12%. So this one we call it as borderline case. We call it as borderline case. And in this one also we are going to use dual symbol as that of that IP in the range 4 to 7 for your fine grain soils. Similarly, we are going to use that dual symbol. And let's say that dual symbol, for example, let's take the example. Let's say that we are having this SW and SC. SW, SC. What this means? This is a dual symbol. What this means? This is saying that first part is saying about the soil and gradation. This is all about the gradation. And second one is talking about the fines, or nature of fines. What kind of fines you are having? That means whether your fine grain part fraction is clay, or whether your fine grain fraction is slit. Okay, nature of fines. Let's say that this soil is, we are going to say this soil is actually well graded sand with clay as what you call as fines, because this is your suffix, that is clay. Said we can say this part, if it was only SC, I would say this, that prefix is S. That means this actual soil is clay, the actual soil type is clay, actual soil type is sand, because this is your prefix. And suffix tells about that fines. Suffix is that, what is the suffix here? Suffix is a C. That means this is clay. So we can say that your soil is actually clay sand. That means this is sand, but it's having a little bit of fines as clay. Clay sand is there. And similarly here we write that we are having this sand S, but this is poor, that well graded sand, and because it's having those what you call as percentage fines in the range 5 to 12%. So because of that, I would say you are having this sand and it's having the those fineness in the 5 to 12%. So that's why we write here that this one as C. That means that C is as a fine. This C is a fine. This C is a percentage fine, and the C is actually clay. So I would say your soil is finally well graded sand with clay as fines. So different combinations can be there. Let's say that which of these are examples. Let's say that few examples we can take. Let's say that your soil is poorly graded sand and it's having silt as fines. Let's say that you're having well graded gravel with clay as fines. Let's say that we are having poorly graded gravel with what you call as silt as fines. Let's say that we are having poorly graded sand with clay as what you call as fines. So these are few examples we can take. These are the few examples we can take. Here we had to note one important thing, that is this one. First one talks about the gradation and second part talks about the nature of fines. Now for calculating the fines, we would say how much percentage of fines we have to calculate. So for the nature of fines, there's one more thing we have to do, that is use of plasticity chart. We have to use the plasticity chart because you can't tell whether your fine part is clay or silt. So for that we have to use the plasticity chart in this case. As that of earlier case for your fine grained soil. That is we can do that. Or that part. And similarly, let's say that your case 3 is there when fines are greater than 12%. When your fines are greater than 12%. When your when your fines are greater than 12%. Case 3 of those coarse grain classification. That means that let's say here we are also going to use, because your fines are more, so we can't ignore them. So we have to use plasticity chart for calculation of whether your fines are clay or silt. So for that, let's use the concept of plasticity chart. Okay, and already we know what is the size. If your 50% of CGPA is, if you're more than 50% of particles of CGP are retained on 4.75, that means this is gravel. Once we got the gravel, now we need to say whether your fines are silt or clay. So for that we have to use plasticity chart. So this is your case C. And in this case we are not going to use the uniformity. We are not going to use that CUCC. We are going to use that combination of the two. That means we got the gravel and we can get either C or we can get either M. So we can get either clay gravel, or we can get either clay that silty gravel. And similarly we can get either clay sand or we can get either silty sand. Similarly, okay, these 4 combinations are possible for the third case. Let's revise all that stuff for your coarse grain soils. Let's revise all that stuff for your coarse grain soils. We say that we are going to use the concept of gradation. We are going to use the concept of gradation. We are going to use the concept of fines, how much percentage fines we have. We are going to use the concept of size. And from the size, I would say size of CGPA, let's say size coarse grain particles. From this one we can get either sand or we can get either gravel. So this part is easy. And for the fines, let's talk about the gradation. And from the gradation we can say whether your soil is either well graded or it's poorly graded based on the concept of CU and CC. So that part is easy. And for the fines part, this is important one. That is the fines part. We can have 3 different cases. For the fines, we can have 3 different cases. Case number 1, that fines are less than 5%. So that means we are going to ignore clay and that means this part is ignored. Which means that we have to use the concept of CUCC for your gradation. We are going to use CUCC concept for your gradation. Okay. And already we have calculated that well graded, whether your soil was what you call as, whether your soil was, based on the size we have calculated whether your soil is sand or gravel, based on the size. Size is must, I would say size is must. Either the soil is sand or it can be gravel. So let's see what is the symbol, final symbol. From this one we can get either W, or we can get either poorly well graded or poorly graded. And from the size we can get either sand or we can get either gravel. So final combinations are there. That is a single symbol. There is no dual symbol. So final symbol is there, single symbol. That is actually it can be GM, it can be GP, it can be SM, it can be SP. So these four are possible. That's well, yeah, this is well graded, it should be M. It should be W. We are saying W. Well graded gravel, poorly graded gravels, well graded sand, poorly graded sand. So these combinations are possible. And for the second case, if fines are in the range, 5 to 12%, 5 to 12%, that means we have to use what concept of dual assembly, dual symbol. We have to use the concept of dual symbol. Dual symbol is there. So we have to use both the parameters. We have to use both the criterias. We have to use both the criterias. One is your concept of CUCC, and it would tell me whether your soil is well graded or poorly graded. And we have one more concept to use, that is the plasticity chart. That will tell me whether your soil fines are clay or whether your fines are slate. This is fines and this is gradation. So final combination is there, and based on the size is must. I would say size is must. Size it would tell me that whether your soil is sand or it is gravel. So final combination is there because we have dual assembly. We have dual symbols. Sorry, we have dual symbols, so we can have different combinations. Like different combinations are there. First one is your gradation. And second one is your what you call as fines. Nature of fines. Let's see what we are going to write here. So I would write, let's have the example. Let's say our soil is gravel, and gradation is that this is well, and nature of fines is that, let's say, we have slit. So this is one of the combination, that we have well graded gravel with slit as fines. Similarly, we can have poorly graded what you call as gravel with slit as fines. Poorly graded gravel with sand as with clay as fines. Poorly graded gravel with slit with what you call as clay as GP. I can write here. What is the one more possibility? Based for your gravel, what is the one more possibility? GM, GC, and GC. Can we write GC? Yeah, I can write here GW actually. GW. Well graded gravel with what you call as clay as fines. So these four are related to what you call as gravel, and similarly four more are possible for your sand. That means SWSM, SPSM, SPSC, SM, yeah, SWSC. It says that we have well graded soil, we have well graded sand with slit as fines, poorly graded sand with slit as fines, poorly graded sand with clay as fines, well graded sand with clay as fines. So these combinations are possible for their dual symbol. So this is the important one. That second one is your important one. So we have to use both the symbols. We have to calculate both CUCC, and we have to calculate one more part, that is plasticity part. And if your fines are more than 12%, that means we have to use single symbol, and we have to ignore what we have to ignore. So in the initial case, we have to ignore plasticity chart. That means we have to ignore fines. Ignore the fines. That means ignore IP plasticity chart. That means we have to ignore. And in the third one, we have to ignore CUCC. That is the gradation. Ignore gradation. We can write in short. This is not mentioned, but we can have perspective of that. Ignore the gradation here. So based on that, I can calculate. So your symbol can be either now, because we are ignoring the gradation, our combination can be either that C, your GC, GM, SC, SM. your soil, that is clay gravel, silty gravel, clay sand, silty sand. That means we are having fineness and we are having soil type. We are having soil type and we are having percentage fineness, nature of fineness. So size is there. It can be what you call as sand. It can be gravel. And from this part we have to calculate only plasticity chat. We have to use only plasticity chat. Plasticity chat. It will tell me whether your fineness are C or whether your fineness are N. Let's take few problems, and this one is very, very important. I would say you can have the final shot of this one. Let me take screenshot also. Okay. Okay. Let's take one problem that we can understand. Let's take one problem we can have. Let's say that we have a soil. One soil is there, and our percentage retained is calculated based on the result. Percentage retained is there. One is your 40%, one is your 50%, and one is your 10%. That means we are having three different sieves. Let's say that one of the sieve is there. Let's say that this sieve is actually 4.75 mm sieve, and one more sieve is there, that is 75 micron sieve. And it should not be actually micron. It's not actually sieve. So let's say that we can have that understanding in this way, because this is not the sieve. Let's have that. Let's say this is 75 micron sieve, and 10% is passing below that. 10% is passing. 10% is passing. So that means 10% of the total is passing that 75 micron, and 40% is retained on 4.75, and 50% is retained on 75. Now if I say I need to calculate one that is called as CU, coefficient of curvature, coefficient of uniformity. I need to calculate that. What is the equation for that? Is that d60 by d10? d60 by d10. I need to calculate CU for this problem. I need to calculate that CU for this problem. That means you have the soil percentage retained on this CU 4.75 is equals to 40%, and percentage retained on 75 micron is 50%, and passing 10 is passing 75 micron. And we can say that this part is less than actually 2 micron. This part is actually less than 2 micron, but it's more greater than 70. Yeah, let's see that this 10% is meaning this 10% means that its size is in the range. Size range is in the range 22 micron to 75 micron. We don't care about this part actually. Our problem is only related to calculation of CU. Our problem is only related to calculation of CU. Can you now calculate based on this one? If only this part of the data is given to you. D60 by D10. We need to calculate what is the value of D10 and what is the value of D60. So based on the definition of those D10, D60, we can get the problem. We can get the solution. So your D10 tells us this is that size of particles. This is that size. Below which only 10% particles are that passing. Below which only 10% particles are passing. From that size, you can write from that size only 10% particles pass. That means only 10% particles are finer than this size. So that means we need to calculate percentage finer. We have studied the sieve analysis. In that case, we were saying that our result was there. We have a particular sieve size, and corresponding to that we have some weight of soil retained, and from that we calculated what is the percentage retained. And after that we said that what is the percentage cumulative retained. What is the cumulative percentage retained? And after that we said what is the percentage finer. So once I get the percentage finer, I can calculate that where is 10% passing. So 10% finer I can calculate now. So can you tell me how can you calculate cumulative retained? So if there is retained 40% on this C 4.75, so I would say your cumulative retained would be 40%. And for on the 75 micron, how much percentage of the total would be cumulative retained on this size? Is that 40 plus 50? Is that 90%? Is that 90%? Okay, we have only two CUs given to you. We have only two CUs given to you, and we need to calculate the value of CU. And from this, can we calculate now what is the percentage finer? Is that 100 minus cumulative retained percentage? So that is actually 100 minus 40. That is 60%. And what is this value? 100 minus 90. Is that 10%? So what is the definition for your D10? What is your definition for your D10? So D10 tells us that this is your particular value of the size. This is particular size. Uh, from that size, if we have particular, if you have a CU or particular pore of that kind of size that only 10% of the total particles are going to be finer than this size. So that means if there is a size such that only 10% particles are finer than this size, so that means this particular size is actually D10. This size is actually that size of the particles. That means only 10% particles are having size less than this particular value of size. D10 is actually how much? 75 micron. We can conclude. What does this 60% means? So this means that for percentage finer is 60%. So if I have that equation, that statement of the D60, it says that this is that size that 60% particles are finer than this size. 60% particles are finer than this size. So we have 60% of the particles that are finer than this particular size, D60. I would say you are having here percentage 60%. That means 60% particles are finer than this particular size. So that means D60 is actually 4.75. So from that I can say your CU is actually 4.75 millimeters divided by 75 micron. So that means you can calculate CU coming to be equals to 63.33. Okay. Let's go for one more. We have our data. We have this data. Let's say that we have this data. This is your sieve 4.75 mm, and there is one more sieve that's what you call as 75 micron. And we're saying that a retained part is there. 40% is retained here. 40% is retained, and on this sieve size, 40% is retained. Okay, 40% is retained on the sieve. 40% is retained. After that, 30% is retained here. 30% is retained here. That means from the statement we can say you are having these three different possibilities, that 40% is here, 40% is here, and 30% is here. That means percentage passing is equals to how much has passed than 75 micron. That means percentage finer than 75 micron would be difference of these two from 100. So that's 30%. Can you say that means your finers are 30% from the problem itself? Can we say that if your 40% of the total particles are retained on 4.75 micron and 30% are retained on 75 micron, that means the difference of the sum of these two, and you subtract the 100 minus the sum of the two, that total value would be actually percentage finer than 75 micron. So that means this is percentage fineness is 30%. So if I say that percentage fineness is 30%, is that percentage fineness greater than 12%? Is that the case 3? Is that the case 3? I would say, is that the case 3? Now, before that, I need to check whether one more thing is there. This is not the start of the problem. This is not the start of the problem. Let's see how we are going to start the problem. This was a sudden jump I took. This was not an accurate way to solve the problem. Let's see all the data that is given to you. Okay, we have that liquid limit given to you. Liquid limit is there for your soil of 35, plastic limit of 27. Okay, All this data are red color is given to you. That's saying retained talk is about that 40% and 30%. Okay, then the solution is in that blue color. So we conclude one statement here that percentage fineness is 30%. Percentage fineness is 30%. Now we need to say if your percentage fineness is 30%, and this is what actually this is actually less than 50%. This is actually less than 30%, 50%. So if your percentage fineness are less than 50%, that means the soil is coarse grain soil. That means the soil is coarse grain soil. So from this one we can say soil is coarse grain soil. So this is first part of the solution. This is the first part of the solution. So the procedure goes from this step. Procedure. Step number one. Step number one is there. See this how we solve the problem actually. So you can have a note of that. Let's see how we solve the problem. Solution to the problem. Any problem where it's given to you. Solution to any problem for your classification of the soil. How do you classify the soil? First point is that whether the soil is fine grain soil or whether the soil is coarse grain soil. So first condition is there. So for that, once we check that whether your soil is coarse grain soil, after that the second possibility, second step is there. If we got the answer that answer is your CGS, then after that we need to check what is the percentage fineness. What is the percentage fineness? Okay, based on that, there is second part, and after that we know what to do. So this is the solution to problem of any general problem we can have, to any general problem. We need to check whether your soil is fine grain or coarse grain soil. Okay. So first step is so we got one statement that soil is coarse grain soils, and from that we would say fineness are only 30%, and one more statement we can get now. Second statement that your what you call as fineness are in the range, that is case 3 actually, case 3. So it's case 3, that means we have to use the plasticity chart. So you should get the concept of that in the mind, that we have to use the concept of plasticity chart here, and only single symbol should be used. Now once I got the concept of that, once I derived that the soil is coarse grain soil, now there might be two different possibilities. So I had to check that whether the soil is coarse sand, or whether the soil is gravel. For that I have to check CGP, coarse grain particles, total coarse grain particles. Let's calculate what is the total coarse grain particles. And I can directly say that 70% are coarse grain particles. So from the solution would be that 70% are coarse grain particles. Because fineness are 30%, that means 70% are coarse grain particles. Now out of that, we can directly say that if this is 40%, if the gravel is 40% of the total and sand is 30% of the total, that means gravel is more as compared to the sand. So I would say your gravel is actually 40% of the total. This is of the total, and this is 30% of the total. And I had to calculate actually percentage in terms of CGP. That is actually we had to calculate 40% of 70%, and this one we had to calculate 30% of 70%. But based on the direct observation, we can say that 40% is more and 30% is less. So I would say that soil is gravel. Soil would be gravel for this case. So soil would be gravel, coarse grain soil, that is gravel. So we got the prefix. Now we need to get now suffix. We need to get the suffix from the plasticity chart. For that, let's calculate value of A line, IPA. IPA is 0.73, liquid limit minus 20. Liquid limit of 35 is there. Liquid limit of 35 minus 20. What is this value coming to be equals to? Is that 10.95? 10.95. And what is the actual value of IP for the soil? What is the value of IP for the soil? Liquid limit minus plastic limit. 35, 27. That's 8. Now compare the two IP. Compare the two values. So your soil value is actually less, but your A line value is more. That means we are having a value of A line. That means your value at that point for your A line is somewhere here, but your actual value is somewhere here. So that means soil is this finest part is M. The finest part is M. We don't have to check whether this is highly compressible, whether this is low compressible, intermediate compressible. That is talk. This talk is all about fine grained soils when we have majority of the soil as fine grained. But this part we don't care here. We say that what is the nature of the fineness for your coarse grained soils, whether this is M or whether this is C. All that stuff we have to check only. So we got the statement that your soil is below the neutral axis. This is plastic, what do you call as A line. A line. Your soil is below the A line. So that means your soil is slit. Your soil is slit. Okay. Your soil is slit. Soil is slit. Okay. So that means your suffix. This is your suffix. That your suffix is M, and that means your final symbol for your solution would be that means the final soil would be classified as G times M. That is the gravelly. That is the silty gravel. Silty gravel. This is the solution for your problem that was all about getting the GM sign symbol. Okay, let's take one more. 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 We are having that what you call as that CU 4.75 mm CU is there. This is our CU 4.75 mm CU. On that, how much percentage is passing? 980 grams is passing. 980 gram passes. 980 gram passes. And there is one more CU. That is 75 micron CU. That is 75 micron CU. How much percentage is passing from that? 270 grams are passing from that pass. 75 micron. Now I need to say for given data, for given volume of the soil was 1000 grams. 1000 grams of soil was given to you. Okay, out of that 980 grams pass what you call as 4.75 mm. That means we need to say on different CU sizes what is the percentage total retained. So let's say this is your 75 micron and this is your 4.75 micron. So I would say your 980 grams can be said as 98%. Is that 98%? Is that 98% out of the 1000 grams? I think it's 98%. So that means 2% have been retained. This percent has been retained that on 4.75 micron. And if 270 grams of the total 1000 grams is passing 75 micron, that means the total percentage passing is actually 27%. Can we see that? Can we say that? So what is the total percentage retained in this condition? That is this actually the sand. That is actually the sand. What is the total sand we can say? What is the total percentage of the sand? Is that 100 minus 2 minus 27? Is that 27, 21, 90, 71? Is that 71 percentage? That means the sand is 71%. If we say that first condition is there, first step is there. If your fineness are less than 50%, fineness are less than 50%, that means soil is coarse grain soil. Soil is coarse grain soil. And second statement is there. Because sand is more. Sand is 71% of the total. Sand is 71% of the total. But your gravel is less, so you can say your coarse grain soil is actually sand. So we got the prefix now. We got the prefix of S. Now we need to check now what is the total percentage of fineness. What is the total percentage of fineness? So fineness are in the range that it's greater than 12%. So case 3 of that condition. Case 3, it says that we are going to use that single symbol assembly. That single symbol. That means now we need to calculate only that plasticity. Because fineness are more, so we need to only solve for the plasticity chart. We need to use the plasticity chart. That means we need to calculate IP A line, and we need to calculate IP of the soil, liquid limit minus plastic limit. So is that data given to you? Yeah, that data was also given to you. That data is also given to you. Let's say that your liquid limit is 40 and your plastic limit is 18. Now we need to say what is the soil? What type of soil is that? So 40, 18. Let's substitute the value of 40 here. 40 minus 18, that's 22. This one is 14.6. So your value of IPA line is less than IP of the soil. So your value is somewhere here, that is 14.6, but your actual value is 22, somewhere here above the A line. That means your soil is that nature of the fineness. So nature of the fineness is actually, your plasticity chart tells us the nature of the fineness is actually clay. So your clay is there. So second, that is the suffix we also got. So prefix we got, suffix we got, clay soil, clay sand we got, clay sand we got. This is your solution. Clay sand is the answer. Okay. Let's take one more. Let's take one more. We can have. Let's take one more. Let's take one more. Let's say that we are having liquid limit 50, liquid limit 50, plastic 35. Let's say that Cu can be calculated as D60 by what you call as D10, and let's say that this is 500 micron by 1000 micron. Let's say that this is 5. Okay, this is the problem we are saying. This is the given data, and there is a Cu. There is one Cu, that is what you call as 4.75 mm, and 36% is retained. 36% retained, and there is one more Cu, that is 75 micron. How much percent retained? 54% retained. 54% retained on that 75 micron. And from the solution now we can say, from this data we can say, you have the Cu, you have one more Cu, and what is the retained percent? That is 36%. And what is the retained percent? 54%. And what is the passing percentage? What is the percentage fineness? What is the passing percentage? Is that 100 minus 36 minus 54? Is that 50, 30, 90, 10? Is that 10%? Is that 10%? Now from that, first step is that. First step is there because fineness are less than 50%, so your soil is actually coarse grained soil. And from this now, because fineness are now in the range 5 to 12%, because the fineness are in the range 5 to 12%, so this is your dual symbol case B, dual symbol case B, case 2, dual symbol. Now we need to say whether this CGS is actually coarse, that is gravel, or it is sand. So for that, we have to check the size proportion. So let's see that. So this is actually 4.75 millimeter. This is 75 micron. So based on these, can you tell me which one is more? Which one is actually more? So I would say because more than 50%, more than 50% of the CGP is finer than or passes 4.75. Can you see that? More than 50% of CGP, that is actually 90 out of the 90% of the total CGP. This is total 90% CGP. Out of that, your 54% is actually contributed by sand. So there, I would say sand is dominant here. The proportion of sand is more. Sand is more. We can say sand is more. Can you say that sand is more? So sand is more. That means the symbol is actually, we got the dual symbol. Dual symbol is there. So that means there is some sand and there's one more sand, such that I have to have the dual symbol. So I should have the dash also. Now we need to calculate plasticity chart. We need to calculate from the plasticity chart that what is the nature of the fines. What is the nature of the fines? And from the gradation, we need to now check what is the gradation. Is that well graded or whether this is poorly graded? And what is the nature of the fines? Is that clay or is that slit? Okay, that we need to now check. So we got that coarse grained soil is actually sand. Now let's calculate CuCc. Let's calculate CuCc. So we said that your solution is that the soil is sand. Okay, soil is sand. Now tell me, if your Cu is less than 6, if your Cu is less than 6, what is that? Is that poorly graded sand? Is that poorly graded sand? There is no need of calculation of Cc. It's not needed because it has failed earlier. It has failed in the calculation of Cu itself. Poorly graded sand. Poorly graded sand. So we got one of the part of the dual symbol. That is, we got one of the part. First one is your gradation. After that, gradation. After that, this is one you call as. After that, we have nature of fines. We have nature of fines. So we say that our soil was sand. Our soil was sand, and your nature of the nature gradation of the soil is actually poorly graded soil. Poorly graded sand is there. GP, that is SP. And after that, we have to now check plasticity, that chart. We have to check the plasticity chart. For that, calculation of IP for your A line 0.73, liquid limit minus 20. Okay, liquid limit 50. Liquid limit is 50. So substitute 50 here. You can get IPA. IPA is coming to be equals to IPA. What is the problem here? Yeah, IPA is coming here equals to 21.9. 21.9. And what about the IP of the soil? What about the IP of the soil? IP of the soil is liquid limit minus plastic limit. That is 50 minus 35, plastic limit 35. So that's 15. Now compare the two. Let's say there that we have this chart, we have this line. Your IPA for IP for your A line is 21.9, but your actual value is somewhere 15, only 15. So your soil is below the A line. Soil is below the A line. Soil is below the A line. That means soil is slit. Nature of the fine is, that means this is slit. Silty fine. Silty. So we can write silty. Okay. So we got the silty also. Now we can write the final symbol. Final classification of that soil would be SP-SM. SP-SM. We said that soil is sand. So sandy soil is there. So let's write the final, that this is poorly graded sand. Poorly graded sand with silt as fines. With silt as fines. With silt as fines. Let's go for one more. Let's go for one more final, I think. Let's go for one more problem. We have that, let's say that liquid limit is 16, plastic limit 8. Okay, liquid limit 16, plastic limit 8, and 4.75 micron, 4.75 millimeter sieve, 92% pass, 92% pass. One more sieve is there, 75 micron, and how much percent pass? 10%, 10% pass. Now calculate. Now get the symbol for your soil. Get the symbol for your soil. Now let's go for the solution. I would say you are having this system of that 4.75 is there. If 92% is passing, how much percent has retained? Is that 8%? 8% has retained on this what you call as sieve size, on this sieve. And if 10% is passing, that means net 10% is fines. So fines are only 10%. So if fines are only 10%, if fines are less than 50%, so your soil is actually coarse grain soil. And your fines are in the range 5 to 10%, 5 to 12%, so it's actually class 2. So that's actually dual assembly, dual symbol. So we have to use the dual symbol now. Okay, this is one step. That is the second step is here, 5 to 12%. Okay. Now we need to say how much percent is retained on what you call as 75 micron. How much? That is 10% fine, 8% retained on 4.75. So you are left with 82%. So 82% is actually sand. 82% is actually sand. So sand, I would say sand is your coarse grain soil. So your coarse grain soil is actually sand. Yes. So we got the prefix. And we have to use dual symbol. We have to use the dual symbol. So solution would be in this way. Dual symbol of sand, and we need to now check your gradation. We need to check your gradation. Either it can be W or it can be P, and we need to check plasticity chart, whether the nature of fines is slit or it can be clay. Now we need to check that. Let's go for the gradation. And let's say that data, let's say that Cu was given to you. Let's say that Cu is actually 1 millimeter divided by 0.14 millimeter. Let's say that somehow you got the CuCC, and let's say that CuCC is coming out to be equal to final value of 7.14, and this is greater than 6. This was given to you. Let's say that Cu, now we got greater than 6. Now we need to calculate Cc. So from that part we got that sand might be well graded. Now we need to check what is the value of Cc. That is d30 square. Let's say that your d30 was given to you as 0.33 square, and divided by that is 0.14 into 1 millimeter. Let's say that these data were calculated from the Cu analysis. It was given to you from the problem. Okay. Now from that you would say your Cc is actually coming out to be 0.77, and that's actually your limit should have been in the range 1 to 3. That means it is falling below the limit. So I would say the soil is poorly graded. So it's poorly. So P would be notation for your gradation. So P. Okay. So we got the final here, that is SP. Now from this side we need to say whether this is SM or this is SC. Okay. Let's talk about the plasticity value, IPA line. Now. What is the equation for IPA line? 0.73, liquid limit minus 20. Liquid limit of 16? Liquid limit of 16 was given to you. So 16 minus 20 and 0.73. So this value might be becoming negative. You can see negative value. Can you say that this value is negative? Is this coming to be negative? And if I say what is the value of IP for the soil? IP for your soil is actually liquid limit minus plus limit, 16 minus 8. So that's actually 8. So your IPA line is below. I would say this is negative value. So your IP for your soil is more. IP for your soil is more. So we can say that clay. So you are having some negative value of that line. You are having some negative value of that line. At that time you are having that clay. You are having that clay also. You are having that clay also. You are having that clay somewhere here. That means it might be in the range, but we have to see whether your one more thing is there. So if I got the value of IP, let me calculate what is the IP for your A line. Let me see that. 0.73 times liquid limit minus 20. That is minus 2.92. So this is negative value, minus 2.92 somewhere here. Let's say that this is minus 2.92. Let's say this is minus 2.92. And at that time, I need to say what is your value of IP for your soil. That is 8. Let's say that 8 is somewhere here. Let's say this is 8. But what about that, what you call as that transition? What was the transition? What was the transition we have? What was the transition? Was that 4 to 7%? Was that 4 to 7%? That if your IP was in the range 4 to 7%, you should have that dual symbol for your fine grain soils. But your value of IP is coming out to be 8. If your value of IP is coming out to be 8, it's above that limit, so we can say this is clay. So we can finally say that this is clay. We don't have to use the dual symbol for your fines. Dual symbol. We don't have to use dual symbol for fines. No, we don't have to use that. That means we don't have to write that this is CLML. No, this is not the case here. But our solution would be that this is actually a clay. This is actually clay in the low compressible zone. But for our solution, we don't care about the low and high intermediate. We only say that this is fine. This is nature of fines. Nature of fines is clay. Okay, let's go for that. Nature of clay is fines. Nature of fines is clay. So final solution would be SC. So that's poorly graded sand with clay as fines. So this is your solution. This is your solution. Okay. Now, is there any one more problem? Yeah, final problem that's we can have final problem. Let's say that 30% retained on 4.75 and what you call as 40% pass 75 micron. This is passing, this is retained. Okay, now calculate tell me what should be our soil. What is the soil classification? And for the value of Cu equals to Cu greater than 8, Cc is equals to 2. This is given to you. Now tell us whether your soil is sand or gravel. So I would say your fines are less than 50%. Because fines are less than 50%, so this is actually coarse grain soil. Now we need to say because fines are in the range Finds are more than 12%, so class K is 3. So K is 3. So we have to use single assembly, single symbol. So we have to use that single symbol. So for that, let's calculate the plasticity. We have to use the concept of plasticity chart, plasticity chart, plasticity chart, plasticity chart. Now, I would say one thing. 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 One more statement is there, that if this is 40%, can you tell me what is the retained on sand? What is the total sand part? What is the total sand part? So this is gravel. 30% is gravel. That means 40% is fines. So finally, I would say 30% is also sand. 30% is also sand. So that means if there was total 60% of the total 60% of the total soil as CGP, coarse grained particles. Out of that, you are having 30% of the total 60%, that is 50%. 30% of 60%, and from this side we are having 30% of 60% as sand and as gravel. So 50% of CGP, 50% of CGP is sand, 50% of CGP is gravel. So I would say which of the symbol we should use here? Which of the symbol we should use here? Which of the symbol we should use here? So for that, if your value is coming out to be same, for that you should prefer higher one. If the problem is mentioning, if the options are such that your both options are there, so you can pick that what you call as higher one. Pick higher one. So I can pick that gravel one. So I can pick that gravel. So but if the options are like you're having that G also there, sand is also there, and you can have MCQ, multiple select MSQ, multiple select question. So you can pick both of those. You can select both of those. Okay. So from the options you can say we are not giving you other data. We are not giving you other data for the calculations of whether the soil is what you call as whether the soil is what you call as having fineness of, whether the soil is having fineness of slate, or whether the soils are having fineness of clay. That part we are not saying. We are not trying to calculate here. We are only saying whether from your options, if your option was given to you as SM, SC, GM, GC, what was the option? So I'm saying in that way perspective. Okay. So final solution would be that you have to select one of the options such that your solution would be corresponding to what you call as G, corresponding to G or S, such that both of the, if both options you can allow, if both options are allowed to pick, you can pick both of those. If only one of them are present in the what you call as options, you can pick that what you call as which one is present there. So let's see that let's say that this problem was mentioned in that way, that our options are, let's say that our options are GW. Your option is one more, that's S what you call as SP. One more option is there. Let's say that one more option is there given to you. That's GWSC, GWGC. Let's say that this is one more option, and one more option is there what you call as let's say that this is one more option of SC. No, I'm not going for SC. Let's say that one more option is there. I'm going to write ML. Which of the options you would prefer? Which of the options you would prefer for this solution, for the final answer? For the final answer, which one you should prefer? I would say your prefix can be either prefix can be either S or it can be G. Prefix can be either S or it can be G. Okay, we got the prefix. It can be S or it can be G. So prefix can be either S or it can be G. Prefix can be either S or it can be G. So I have three options. So three options are there. Now, second statement is there. Because percentage fines were given to you. What was the total percentage fines? So 40% are fines. If the 40% are fines, that means it's corresponding to class. It corresponds to class 3. So class 3 says that if this one is there, that means we have to use that single symbol. We have to use single symbol. So that means this part is getting cancelled. This part is not the option. This is not the option. So now we need to see whether these are, out of these two, which one is there. Now I would say I would say that based on this, based on the problem itself, based on the problem, it's not given that, whether it's the data related to plasticity character is not given. It's not mentioned there in the problem. Related to the plasticity character, it's not given in the problem that you can calculate IP for your soil. So based on that, we would have tell that whether your soil fines are M or clay. That was not given to you. Only the data that is given to you in terms of gradation. So from the gradation, I can say from the gradation your Cu is greater than 8. That means it's well graded. Either you can take sand. For that you have condition of greater than 6. For the gravel we have condition of greater than 4. So this is greater than 8, so we can say this is okay. And Cc is also in the range 1 to 3. So I would say your soil is actually well graded. So your soil is actually well graded. Now I would say that I would go with option A. I would go with option A because this part was not we can't solve it. We can't determine whether your soil is whether your this is poorly. It's saying that soil is poorly, sand is poorly, but this is not the true solution. So final solution would be in terms of gradation. In terms of gradation, that your soil is gravel with well graded gravel. But the actual solution of this problem would be according to classification system. That should be according to classification system. It should not be GW. It should not be GW as per the actual classification system, as per the ISSCS. So, but if the option came such that this was one of the options, but all other data related to that fines was not given, so we should go with this gravel, and that is well graded gravel. So that was all of that classification of the soil. Thank you for watching. Thank you for watching out. Okay. Thank you.